So let's send a request from Postman and show you what I'm talking about. So send, come here. So go to the console, increase the console size, clear it. So here, by the time it reaches this logger, we have the payload, which has 4 elements that we see here. And we have the variable, we have one variable, which is max of payload 400. Then we click next. It came to the pile for each scope. Then it is applying 10% discount to each element. So the payload, the first time is 100. Second time is 200. The third time is, so this is in parallel. It is not in any order. So that's why we see 400, then 300. Now it goes to the next operation, the next component set variable. The same thing, it is iterating over the variables. Then we have a logger here, just line breaks. Actually, this one is not important here. So here it printed the, what it's printing here is the payload, and the variable is what we are printing. So I can clear this. Next. So the first time the payload is 180, which is 10% discount of 200, which is 200 times 0.9, 180, and the variable value is 410. Next one, we have 90, which is 10% discount of 100, and the variable is still 410 because in parallel for each iteration have, just since it is in parallel, they have the original variable. So one iteration doesn't have visibility to what's happening with the other iterations. So the same variable for value, previous variable value, which is max of payload, which is 400, in each iteration 10 is being added to it, is what we are seeing. And after that, it comes here, it exits the parallel for each, and here let's see what it is printing. It prints, as you can see here, it prints the results from each iteration. So our payload, our original payload has been lost, basically. That is what I am trying to say. So what if we want our original payload, the payload here, after applying some discount to it, we want to do something to it also, or merge it with something, or enrich it. In that case, we don't want to lose it. What do we do? So in that case, you just click parallel for each, and the results of parallel for each, you similar to what we were doing with flow reference, you just save it as a target variable. So this target variable, for example, I can just call it payload. So this is a variable name, and let's save this. Okay, and clear the console. Let me make sure it updates successfully. Okay, so basically, yeah, the output of the parallel for each, we are saving it as a variable under the target, giving it a target name. Okay, scheduler unavailable. I don't know which scheduler you're talking about. Okay, let's see. Let me resume it and see if it works. Okay, clear. Send a request now. Come here. Okay, maybe I may have to redeploy it again. Okay, stop. Run in debug mode. So we did this. We saved the payload as variable when we use flow reference and also HTTP request. We have seen it a couple of times. The same thing. We have the same functionality with parallel for each also, if you don't want to lose your original payload. So once this is done, we'll start today's class, today's topic. Okay, so clear this and go and send. I'm here. So I have the original payload. Now what we want to see is once it finishes and exits the parallel for each, do we have the original payload, and the output from the parallel for each, it should be as a variable called payload. So we can access it using vars.payload. Okay, so click just next. So it is here. Now what do you see? You see the payload is, we have our original payload, and the variable is, I use it, the variable, it depends on the name. I mean, so when I printed variable here, I use it vars.max payload. Had I used it vars.payload, which is a variable name here, vars.payload, then it will print the output from this parallel for each. But we can see the output from parallel for each saved as a variable here. If we just click here, we have a variable called payload, and we can see its content here. So this is a variable, and it has 4 elements. So these are output from each iteration. With the information, we can see what information each one of them have, the value. We should be able to get it here. You see the value here, it shows 90. The other one, if that is for 10% discount applied to 100. If you go here, also we see 180, which is 10% discount applied to 200, and so on. So the main thing is, you can experiment with this in parallel for each, not to lose your payload. You can save it as a target variable. Okay, that's enough on this. And I will close this and start today's topic, which is very important topic. Unfortunately, many people have not joined today. Close this. Okay, so we are talking about, let me close yesterday's slides and start today's slides. So we are talking about so in this class we are talking about batch job scope. We will understand its mechanics, how it works, and also we will understand how it works using simple examples that I have as quizzes, and then we'll have real-time application processing massive volume of data using batch job and inserting the data to a database. In our case, we are going to apply discount to the diamonds data, which has I think around 54,000 rows, and insert it to the database. Last time we applied the discount externally in Excel, but today we will see how we can apply the discount itself in MuleSoft using batch job. Okay, so as usual, the project and the quizzes are on the repo. Before we start batch job, let's quickly review async scope. Async scope, we saw it in week 7. So batch job, it processes data in batches asynchronously. So it is important to understand the behavior of asynchronous processing. So the async scope is a branch processing block that executes simultaneously. So it processes simultaneously with the main flow, and it doesn't wait. The main flow doesn't wait for the async scope to complete. Like for example, in week 7, we saw we downloaded from data.gab large volume of data, vehicle crashes, and downloading the data took a couple of minutes. But on Postman we got a response because the main flow completed. So the main flow doesn't wait for the async scope to complete, and we use async scope especially when we have applications that take large volume, that take time, such as processing large volume of data and pushing it to queues, downloading data, or inserting to databases, and so on. And this figure shows how it works. So we have a mule message coming, then we have an async scope. So the message is going to the async scope and also to the next processor after the async scope at the same time. And the async scope continues its processing in parallel, and the main flow also continues to the next parts of the operation. And we saw async scope is like fire and forget. It works in a fire and forget manner. So for that reason, the variables and payload from the async scope are not accessible in the main flow. So having said that, we will now see what batch job scope is, and the documentation is really it is really nice documentation. So I have added a link to it here on batch processing. All of the content that I have in my slides, I just added them from here. Go over this, read it line by line. If there are some concepts that you don't understand when you read the first time, just give it time, or read additional resources also, especially practice more. Just do the hands-on, and then when you read the concepts, you will understand it better. But batch job, what we are talking about is let me open the simple examples I have. Then when I show you, before we go to the slides, we just want to see the different components of batch job and how it works. So let me create a new flow. So if you go under core, there is batch job here. So this batch job, let me drag, if you just drag and drop it here, I'm dragging and dropping it at the bottom. So you see at the bottom I have batch job flow, and it has, so this is a source. It can be any source as usual, and then you will have any processors after that. Then under batch job, we have two main parts: process records and on complete. And under the process records, we have two steps: processors and aggregator. So we are going to understand what these ones are and what the use of each one of them is and how to set them up. So this is one batch step, as you can see, and we can have multiple batch steps. If you want to just add another batch step, you come here and drag and drop batch step here. So I have another batch step again. So the first batch step has processors and aggregator. The second one also has the same thing. You can continue more, as many as you want, based on the application you have. And in the box that says aggregator, to aggregate data, we bring this operation batch aggregator. So I have to drag and drop it here, for example. This is a batch aggregator. We will understand what batch aggregator is and how it works. So this is batch scope. It has these components. So how is it used, and what are the different steps? How does it behave, and so on? Let's see. So we said it processes data asynchronously. It splits large messages into records. So see this one, what it says is flows process messages, whereas batch jobs process records. So batch job processes the data at record level. That's very important. Batch jobs, they process the data at record level. And so how does it process the data? It splits. It can be streaming data or any kind of data. It splits the data into individual records and processes the records at individual level upon each record. And this helps. The use of this one is, since it is processing at record level, it helps us to handle any kind of errors. When there is an error with processing one record, that doesn't cause the batch job to stop. So we can configure that so that it completes processing all records, even if there are failures. And yeah, it processes, we are saying it processes it asynchronously, and at the end it reports on the results. So that is what we see here. At the end here, you see on complete. So this part, on the on complete part, what we get here is like a summary statistics. 10,000 rows were processed, 10,000 records were processed, 5 of them failed, and the rest were processed successfully, for example. Such kind of summary statistics, we get it on this stage, when it gets on the complete stage. So that's what this one is saying. And so the use of batch job is usually to process large volume of data, and either in the, we will see with the example is either in the processor stage or in the aggregator stage, we push the data to some data store, or we can push it to queuing systems also. Okay, so batch job. So we saw with VM connector, if you remember, we said we can configure it either in memory or persistent. So, and we said persistent is slower, but it is more reliable because it writes the data to disk. It is the same concept is here also. It writes the data to disk. So because of that is the reason that we can process asynchronously larger than memory data sets. If you have large volume of data that doesn't fit in memory, you can still process it with batch job because it will just take chunks of the data from the disk. So, but the other cost that you can see here is there is disk I/O, or it reads and writes data to disk. So that also takes time. So it is reliable because it is writing the data to disk. And for some reason, if your application fails, it can resume from where it stopped because it is writing the data to disk and it keeps track of where it stopped, what it has done, and which ones have failed, and so on. So that is what we see here. Is the image at the bottom that you see is we have a pool of data, persistent data. From the persistent data, it is going to take chunks of data, chunks of records, then process each chunk. And once the first chunk is complete, then it goes to it brings another chunk, and so on until all the data is completely processed. And if it fails while before completing, it is going to resume from where it stopped. So some example use cases, there are lots of example use cases that you can see from the documentation. Also, it is used for integrating data sets to parallel process records. This can be small, large, streaming or not. Especially this is more suited for large volume of data because if it is small, you can use for each or parallel for each. But when you have large volume of data that doesn't fit in memory, or when you use parallel for each, that fails, that gives you out of memory error, then batch job is the right approach. And another application is engineering near real-time data integration for synchronizing data sets between business applications. Like, for example, in my company, we have different databases that we store data. One is used for all our applications, our website, and so on. So it should be up to date. But we have other databases, data analysts, data scientists, and so on use. So the databases that the data scientists use, it should not be necessarily up to date. It can be synchronized once a week or twice a week. That is what we do. So you have one database which is up to date, getting all the data coming in real time. But the other databases that are less frequently used, you can synchronize them with the database that has truth data a couple of times a week or once a week. And for such applications, we use batch job. And another example is like what we see in today's class for ETLing data into target system. So ETL stands for extracting, transforming, and loading. So if you have CSV data, for example, you read it from the CSV data, you do some processing, and you insert it to databases. That is ETL. So batch job is one application of such problems or such examples. And in today's example, we are going to apply discount to our diamonds data, which is in CSV file, or it can be in any flat file, and then insert it to MySQL. So batch job contains three different phases. The first one is implicit. It is load and dispatch. So preparing the data, creating a copy of the payload. This is done behind the scenes. It splits the payload into a collection of records and creates a persistent queue and stores each record in it. So the message that comes in the batch job, the payload that comes into the batch job, it splits the payload and it creates a collection of records and it persists the data into queue. So as you can see, it is creating a copy of the data. The second stage, which is required, is processing. So under the process, which is this one, so process, we are talking about this stage now. The first one is implicit, we don't see it. The dispatching, load and dispatch, we don't see it. But the second one is processor. So we can drag and drop different processors here. From the different processors we have, I can set some variable, I can set some payload, I can transform data, and so on. Transform message. And in here, if I want to insert, so the first stage, which is a processor, it processes the data at record level. So it processes it one by one, whereas the aggregator, it aggregates the data. So if we see under aggregator, if you come here, under aggregator, we have aggregator size here. So once the data is processed at record level, how do you want to aggregate it? You can specify aggregator size. For example, if you are inserting data to database, if you go, let's go to database, insert from database, we can put insert here. So it will insert each record one at a time. So it is going to insert each record. So there will be multiple connections. Send one data, disconnect, connect again, and send another record, and so on. So it could be slow. It will be slower, especially when the data is not small. So rather than doing that, we aggregate the data. Let's say if we are inserting to MySQL, rather than using insert, we can bring bulk insert here, and in the aggregator, we specify the size. How many records do we want it to aggregate first before sending to the database? It can be 100, or if I want all of the records to be sent at once, I just can use streaming. So as you can see, if I select streaming, aggregator size is disabled. If you specify aggregator size, streaming doesn't work, and vice versa. You can just specify one of them. So this is the aggregator. It aggregates. The processor processes the data at record level, and inserting to a database, or doing other kinds of manipulation. If you want it at record level, you do it in the processor step. But if you want to aggregate it, drag and drop aggregator. From here, you drag and drop aggregator to the aggregator box, and you specify the aggregator size, how you want to aggregate it. So these are the concepts in the next slides we have. So the processor processes asynchronously. It processes the records asynchronously, as we said, and it contains one or more batch steps also. So that is what we have here. We have multiple batch steps. The first batch step has here, it can have multiple processors, as you can see. We have another batch step, the same thing, another batch step, and so on. And this one becomes more handy, especially when you have multiple batch steps. It becomes more handy, especially if you have data, for example, you want to manipulate records, but some of the rows may fail for some reason. In that case, the rows that failed, you may want to do something else in the second one, and so on. So we will see how to specify the exceptions to handle that also. And the third component is onComplete, which is just optional. If we just leave it, it is going to report the summary of the records processed, how many were processed, how many failed, and so on. This gives us insights on which records failed, so that we can take care of that. We can, for example, build some kind of alert if there are records that didn't process, or we can create a dashboard which shows records that failed. And as I said, a batch job contains one or more batch steps that act upon records as they move through the batch job. And when the batch job starts executing, Mule splits the incoming messages into records, stores them in persistent queues, and queries and schedules those records in blocks of records process. So this one, see this one. So from the persisted queues, once the payload comes, it splits it into collections, and it persists it, creates queues in disk. Then to memory, it brings blocks of records, and by default that value is 100. we are going to you are going to experiment how changing that block size impacts the performance. So if I come here under batch job, if I just click here, you can see batch block size. So from the records you have, if I have 10,000, for example, it is going to persist the 10,000 rows in disk, records in disk. First time it is going to bring the 100, process them, then another 100, and so on. So if the data is large volume of data, and if you have more powerful computer, you can increase this batch block size. And I have in the assignment with the diamond this data by changing the batch block size, see what batch block size is more optimal. So it can vary from application to application what the optimal size should be. So we have to experiment with that to get the optimal batch block size. So that is what this is saying. We can customize this, and after all the records are passed through all batch steps, the runtime ends the batch job instance and reports the batch job results, indicating which record succeeded, which record failed. Basically, it gives a summary of the performance. So we'll come and see the rest of the slides. Let me show you with the examples I have here, step by step. We are going to see. I'm labeling them as quizzes, but we can call them examples also. So I have 4 examples. I want to understand the scope of batch job in these examples, and then we have inserting the data, like almost like real-time application, inserting data to database. This one, the first one, as you can see, I have a listener, and I have a payload which has a values 1 to 3, and the variable is maximum of the payload. Now, this batch step, it is going to take each element one by one and apply. The variable is simply the payload times 10, and in the transform message, I have the payload plus 1. So basically, first one is, if it takes 1, then this will be 2 plus 1. When it takes 2, the transform message will be 3, and so on. I have a logger here that prints the payload. And for now, for this first example, we are not putting anything in the aggregator. We just want to see the scope of the variable and payload. Now we have, after that, we have on complete. On complete, I am printing a payload. The payload to see what the payload is. Do we have access to this payload? We want to understand that. And do we have access to the variable from the batch step? We want to understand that too. So in here, the variable name is var2. We can see if the var2, if we can access it on this onComplete stage, and also outside of the batch job scope. So let me run this in debug mode. The last one is simply for just to be returned to Postman, flow completed successfully. So since this is asynchronous, what it is going to do is once it comes to the batch job, it is going to just skip to, it is going to exit it and go to this logger because it is asynchronous. And before it completes the batch job, we'll get a message in Postman. So let me show you our listener. What is a path? Okay, it is batch job, batch 1. So let me send a request. Batch 1. So the goal here is understanding the scope of the variables and the payload with the first example. That's what we are doing. Is this work? Okay, it is deploying. And we will have 10 minutes break from 3:55 to 4:05, 10 minutes. We are going to use our time as optimally as possible because the concepts of batch job are a lot, and it is worth experimenting with as many concepts as possible. Okay, this one has been deployed, I think. Now I can send the request. Let's come to Endpoint Studio now. We see, okay, come here. So it has stopped here because I have added a breakpoint to the batch job itself, not the components inside it, but the batch job itself. So it is here. Now I have the payload, 3 elements, 1, 2, 3, the variable maximum of payload, which is 3. Okay. Now click next processor. When I click next processor, as you can see, it skips the batch job and it has exited it, and it has stopped in this logger. So the concept here is, it is just like this one. So it sends a message. It was in this batch job. Before completing this batch job, it goes to the next processor in the main flow. That's what we see here. So it is in here. Let me clear the console and see what it prints. And we say the reason that we reviewed the async scope is, in async scope, we don't have access to what happened inside the async scope in the component in the main flow next to the async scope. So here, if I click next processor, what do we see? You see, this is, what do I have here? This is just end of flow to show us that it has passed this. And if I come to Postman also, let me click the next processor here. If I click next processor, it comes to this transform message. Then after I click this, now I will see in Postman a message that says the flow completed successfully, but actually the batch stop has not completed yet. The payload, you can see the payload now. In the batch step, since it is processing one by one, our payload is 1 the first time. So it is going to create a variable also. var2 is simply the payload times 10. So that's what we see, 10 here. However, the other thing is, the variable that was created outside of the batch job is accessible inside the batch job. That is point number 1. Payload and the variable that was accessible, that was created before the batch job, is accessible inside the batch job, whereas the payload, it divides into records and processes it one by one. So that's what we see here. Click next. Let's see what it prints in this logger. Clear the console and click next. So you see it has printed, we are printing the payload. So it printed 2, which is 1 plus 2. Since we added 1 to it in the transform message, the payload has been updated to 2. Now when I click next, again, now the payload is 2. It took the second element. And then added, the variable is the payload value times 10. So it will be 20 in this case. That is, var2 is 20. The first variable out of the var1, which we created before the batch job, it still remains the same. So now when I click next in this payload, this logger, it is going to print the new payload, which is a new payload, which is 2 times 10 from this transform message, since we are, plus 1, yeah, since we are adding 1. We are adding 1 here. Okay, yeah, it is a variable that we are multiplying by 10. The variable we are multiplying by 10, whereas the payload we are just adding 1 to it. So clear this. Okay, go next. You see, we see 3, which is 2 plus 1. And again, we see it printed 4. So it printed all of the payloads one by one. So basically what you have to understand here is the batch step in the processor, it processes the records one by one. And it has access to the variables that were created before the batch. And on complete, on the other hand, on complete, the payload is a summary statistics, and it doesn't have any access to the payloads that were created inside the batch step, and it doesn't have any access also to the variables. So once I come here, as you can see, I am in here on complete stage. You can see what our payload is. It is some summary. See, successfully recorded 3, total recorded 3, failed recorded 0. So summary, just summary. That is our payload. So our original payload is not accessible here. And what about the variables? You can see the vars also. We have var1, which was created before the batch job. So the variable that was created before the batch job is accessible anywhere, but variables that were created inside the batch job are accessible only in the batch step only. They are not accessible on complete stage, because we created var2 here, but we don't see it here. We just have only var1. That's what we see. So this payload, I can print it. Simply, it will print this summary statistics. So if I click here, you can see on the bottom, I have totally records processed 3, successfully records 3, failed 0. So it processed the elements in the payload. So that's the first example, a simpler example. The second one, in the second one, we can apply filters to the data that we want to process. So in this case, I have some CSV data. Let me show you. Oh, that data I will push it to GitHub, or you can experiment with yours also. I just created sample diamonds data with just 4 records. I have these 4 records. So let's say I want to apply 10% discount only for the prices that are more than some value. Increase this font to show you. So I want to apply prices, this 10% discount to some of them. Let's say to values greater than 340. What do I have here? So in the first batch step itself, we have policies here, accept expression and also accept policy. So what do we see here? You can give it any name. The name is just for us, display name. You can provide accept policy here, and the records that return true will be executed. So here I am saying payload.price greater than 140. So which ones are greater than 140? Only these two. So only these two will be processed in the first cycle, in the first batch step, I mean. So here, since I have this price greater than 340, it is going to process the values with values greater than 340, and we are applying 10% discount to them. Basically, we are multiplying each value by 0.9. So our price now for these values will be the original price times 0.9. I can come to Excel here. So step 1, price will be simply 0.9 times these values. So one is 110.5, so one is 121. Okay. And yeah, so that is what we get from the first batch step here, 10% discount. Still, we have not yet looked at Aggregator. We will look examples with Aggregator later. Let's understand the batch step first and filtering the data. We can apply filters, simple filters to it, the records that we want to process. And then we have a second batch step here. As you can see, I have 2 batch steps. This one is one, another one here. Now, let's just, for the sake of understanding the scope, what I am doing is I am now processing, I am just returning the records that have price value less than 330. So from the first batch step, what gets transferred to the second batch step will be, it will be like this. So the price from the first batch step, these are what will be transferred. The price values will be updated only for these 2 rows. Oh, so I will have to copy, apply this copy and paste values. Paste values. Oh, okay. First, let me paste it somewhere else. Paste values here. Then from here, copy it and paste it here. So in the first batch step, the price values for the last 2 records have been updated. Increase this to 18. So that is what we see. That is the first batch step. Okay. But what gets transferred to the second batch step is not only these records, the whole payload gets transferred. So that means all of the records, including these ones, will be transferred. So in the second batch step, I am filtering those that have values less than 330, returning the values that have less than 330. Payload.price less than or equal to 330. So that means at the end, what I should get should be, this one should be excluded. and the rest are less than 330. So I will get this one and these two as output. Now let's see if we get the same thing in MuleSoft. Okay, so clear the console, and this is, I think the path is batch 2. Send a request, send, come here. Okay, it has read the data just using read CSV like what we have been doing. It creates an array of 4 elements. Each element is an object, and it has stopped in the batch processor. So I can click next. It will go to the next component in the flow, and click next. Now it comes to the batch processor. Clear this. So you will see it applies 10% discount only for 2 of them. So this is, since it is asynchronous, when you click, when you run it in debug mode, the way it moves, it is somewhat weird. So it is not intuitive sometimes. Don't worry about that. Now let's see what gets printed to the logger. We'll compare the results with what we get in Excel. So we have 310.5, that is from the first one, which is this one. Since it was greater than 340, it applied 10% discount and it became this. That is what we see here. That's what it has logged. If I click next, we see the second one is 721.3, which is this one. Now in the next processor, the whole payload is accessible, and from the whole payload, I am just returning to the console only the ones that have price less than 330. So click next. It is in here. Now here the key is final price. Before it was price. So it will return the values that have less than 330. We see 326, which is this one. Then it will return this two. Let's see. Click next. Click next. See 310, which is this one. And last but not least, it is going to return, which one did it return? It returned this one, 721.3, which is this one. And then at the end, since it goes to the incomplete stage, it prints this summary statistics. Total record is processed 4, successful record is 4, and 0 record is failed. So what is the main take-home message here? So we are processing record by record, but in each batch step, we can filter the data that we want to include. And however, you have to remember that what gets passed to the second batch step is not only the data that was included in the first batch step, but including the records that were not processed in the first batch step. That is what we saw. So that is example number 2. Now let's understand the third example. The third example I have. Now we are using batch aggregator. Let's see what we are doing here. So I have dummy payload values. We are applying 10% discount. So the values will be 1,900, 1,800, and 2,700 and 360. And in batch aggregator, we are aggregating the data. You see this one, aggregator size. This is very important. Aggregator size 3. And also you may see in certification questions or other questions also with exhibitors, when you this batch aggregator size 3, you can see it in the XML code also. If I go here and show you where it is, batch aggregator, this one, and if I scroll to the right, size is 3 is here. So in a question you can't see, they may include a screenshot like this. You have to pay attention to the size here, the batch size, because what gets printed or what it returns, the result that it returns, the structure of the data, it depends on the batch size. Let's see that. So here in my batch size, I have 3. So that means it will create arrays of 3 elements. In this case, I just have only 4. So the first one, it will one by one in the batch step, it is going to apply 10% discount to each one of them. Then it is going to aggregate the elements, the new results from the batch step. Once it gets number of elements which is equal to this, then it is going to print it to the console, or if it is inserting to the database also, it is going to insert that. It doesn't wait until all the data is processed. It just needs the specified size, number of elements with the specified size. But if we just select here streaming, it will wait until all the data is processed. So let's see this one. It is, the path is batch 3. So I will send a request again so that we can understand how it behaves. And we will change the batch size also to see how the results change. So the payload initially, just this payload values, click next, and come back to the batch step. So it is going to process the first element, 1, see payload 400, we see. Since this is asynchronous, it is not sequential, so the order here, there is no order, it doesn't keep order. So we see the payload now is 400, it will apply 10% to it, which will be 760. Another one, it brought the second element, another element, which is 3000 and 2000. Now, since it got 3 elements, it went to batch aggregator, and batch aggregator now it is going to print the payload. I'm just printing the payload here, which is 10% discount applied to the 3 elements. You can see the payload here. If I just click it, these are the payload values after applying 10% discount to the first 3 elements that were processed successfully in the iterations. So click next. So we see that here. You see here, it printed these payload values. So the array size in this case, it has 3 elements because my batch size is specified as 3. The last one, since I just have 4, now it will not, once it gets the last one, it is going to just print that because we don't have, we have only 4. So it will print the first 3, then it prints the next one. So click next, and as you can see, it printed just an array of element 1. You see square bracket here, and inside it we have 1800, which is 10% discount applied to 2000. Now let's change the batch size, and you can see if I change this batch size to 2 and save it, now it is going to print 2 elements in each array. Clear this, send again, come here, click next, next, 2. Okay. Now my payload has 2 elements. These are the values. That's why after getting 2, it went to batch aggregator. Then it prints. You see now, you can see it just printed only 2. Before it printed the first 3. It has to wait until 3 elements get processed. But now once 2 get processed, it goes to the batch aggregator. And the last one also, it prints 2. Where is it? One is here. Another one is here. Okay. The other thing that we can experiment is we can select here streaming. In this case, it will first process all of them before going to the batch aggregator. So save this. I think I will push our break a couple of minutes. Let's finish these examples, and then after break we will go to the real world example. Okay, so now clear this, the console, using the clear button. Click send a request again. Now next processor, clear the console. Let's see what it prints. So it processes all the values in the payload first before going to the aggregator. If I come to payload now, you can see the size of the payload. Where is it? Oh yeah, if it is streaming, it doesn't print. Okay, this one, it processes it and it doesn't print it to the console, I think. Okay, yeah, it doesn't print it prints. Yeah, leave this one for now. So yeah, at the end it just printed a summary statistics. But if it is streaming anyway, it doesn't print the console. But if it is streaming, as you saw, it first processes all the elements in the array. Let me change the size to 3 and continue to the next example. Our last example, we have, okay, what do we have here? So in the batch steps, we said we can include a policy or accept expression to specify the kind of records we want to process. So if you see in here, my payload, it includes numbers and letters, alphabets. I have A, B. So here I am trying to apply 10% discount. You cannot multiply A and B by 0.9, so that will give an error. And in the batch step here, you can specify accept expression. So here I am saying, since the payload will come one element at a time, first it checks if the payload is a number. If the payload is a number, then it is going to be processed in this batch step. Otherwise, it will not. But remember, since this is an expression, we have to use this # square bracket and put data with expression here. So let me show you this one. Path here is 4, batch 4. So send again, and so in this case, I didn't put any breakpoint. So let's see what it printed. So in this batch aggregator, what's the size we have? Batch aggregator is streaming. Let's see what it printed. So it printed, as you can see, it applied 10% discount to the numbers, and it printed all of them. Since in my batch aggregator, since I chose aggregator size here, since I selected streaming, it processed all of them and printed the results as all of the elements in one array. So you can, the take-home message in this example is you can specify accept expressions here. So this is batch job. As you can see, it is very customizable. It is very powerful. And in the after the break, we are going to see importing the CSV data to the database. But before that, let's make sure we complete the slides here and cover the concepts. So batch job, the data that it can split is these 3 data types: Java, JSON, and XML. If your data is something else, like CSV, for example, first you have to transform it to these formats. And usually, Java is faster. The data format in Java is faster. And this note, the other one, this one, is, it says a batch job instance does not wait for all its queued records to finish processing in one batch step before pushing any of them to the next batch step. Yeah, this is what we have seen. It processes the records in each batch step is processed sequentially. The other thing, each record. So if it takes one record, for example, it gets processed in the first batch step. So let's say we have one record. Let's say an example that has 2 batch steps. First, it has to be processed in this batch step before it goes to this batch step. And with each record, the variable that was created in here is also accessible in here, and so on. Whereas variables that we create in the aggregator are accessible only in the aggregator. You have to practice more and read the documentation to remember these concepts. It is somewhat lots of concepts. Okay, and in here what do we have? So behavior with aggregator, this one we specify the batch size. You can specify the size, or you can specify streaming. And if you specify the size, what it says is after the batch step processes a record, the batch step sends the record to the aggregator for further processing, and the aggregator continues processing records until the number of aggregated records reaches the configured aggregator size. Like when we're running the examples, when we specify the aggregator size of 2, once it gets 2 elements processed in the batch step, then the aggregator aggregates them and prints it to the console. Whereas if it is streaming, it has to aggregate all of them. We saw also specifying the accept expression, accept policy. Yeah, in the accept policy, this one, another concept is when you go from one batch step to the other batch step, you can specify in this batch step, I can specify, for example, process only the records that failed in the previous batch step. So here you have only failures, no failures, and all. So you can specify the accept policy. If you want to process only the records that don't have that didn't fail, or the records that failed in the first batch step, for example, you may process your data and you may have some failures. Then in the second batch step, you may want to handle it differently. Another important concept is in the batch step itself, there are a couple of things that we have to specify. Let me go and show you. Okay, let me get back to design mode. So batch step here, what are the hyperparameters or values that we have to specify? This one, max failed records is 0. What this one is, to if any record failed in the first batch step, for the records to be passed to the second batch step, what is the threshold here? So if it by default it is 0, that means if there is any failure in the first batch step, all the records will be processed in the first batch step, even if there are failures. But if there is any failure, then the second batch step, it will skip it and go to the incomplete stage. You can specify any numbers that you are comfortable with, or if you are fine, if you want to say process in the second batch step also, even if there are any number of records, here is specify -1. -1 means I am okay with any number of errors. Any number of errors, I want it to pass to the second batch step also. The batch block size, this one, we will see for the batch step stage. As you can see, the batch block size is 1 because we are not experimenting with other values today, because we have to first see, for our case, we have to first see the data with function mapping arrays to other kinds of arrays. So we are just passing only one record at a time to the batch step, but it is possible also to pass a block size, a couple of records, and then process those records in that batch step. So these are the concepts we have with batch processing. After the break, we are going to see the example we have, the real world example we have. So it is applying 10% price discount to the diamonds data and bulk insert it into my SQL. We will also discuss why we are using bulk insert. And I have an assignment at the end. You are going to experiment with the batch block size and get the optimal batch block size to insert the diamonds data to the database. Also, you will experiment with aggregator size. Shall you send the whole data at once, or shall you send it in chunks, or shall you send one record at a time? What is the optimal time? I have this assignment. But now let me give you 10 minutes break, and after the break we will meet and complete this part. At the end, on the uncompleted stage, it gives a summary statistics. So the payload, the original payload, gets lost, and the variables that are created inside the batch step are not accessible outside of the batch step because it is asynchronous processing. And we said it has 2 steps. So let me drag and drop it here. Batch job. So it has processors and aggregator. So on the processor, we can, what makes it very versatile is on processor, you can drag and drop different processors from the components you have here. And on the aggregator, we aggregate the data, and usually this becomes more useful when you are inserting the data to some data store or writing it to disk. So let's see an example that looks like a real-world example. I will meet you again and take questions later. So okay, so we are working with diamond data. First, we'll understand. I think we have seen already how, with the examples we have seen, we ran it in debug mode and we understood how it works. So I can remove the loggers here, remove this logger, and I don't think I need. Okay, that's okay. Let's repeat it. Let me add a breakpoint here, and other breakpoints here, and I have another logger here. So let's see what it is doing. Since we are processing large volume of data, we don't want to run it in debug mode. Let's just process only a few records. And let me run this in debug mode. It's not running. So run it. Say batch job. I have sample diamonds for keys. Yeah, we can work with this one also, because we are iterating by clicking next, so we don't want to have multiple records. That will take so much time. So let's just process only some records. So from the diamond disk, just if we click it, it has, I guess, around 54,000 rows, 53,794. Let's just take the first few on this records, copy, create a new Excel and paste it there. And we have, so the source trigger I have here is on new or updated file. Let me see where the working directory is. The configuration here. Can create your own configuration. So I have batch processing input. So I will save this data to that location. Save this. Batch processing input, it is this one, and give it sample.csv. I will save this as CSV. Comma delimited, save. Now it will pick this data, and we will see here it has read it in, which is a payload as array. It has 5 records, 5 or 6 records, the records we included. So we can also see we created a variable here. So the data, one of the things we said is in batch job processing, the data should be either in Java, XML, or JSON. And in our case, since it is CSV, we are transforming it to JSON here. That's what we just did. And here we are checking the number of variables, and we have the number of records, the size of the payload, and it shows here. Okay, it shows 20 records. Did I include 20 of them? Okay, yeah, this records. So in the logger, it is going to print what it is printing, just the size. So I am creating a variable. The variable name here is var_before, and it is the size of the payload. We will see this variable will be accessible inside the batch job, including in the aggregator stage. Clear this, click next. So the variable is 20, is what we are seeing here. Then it will go to the component next to the batch job, these loggers. We have seen all of these. So come here. Okay. What did it do? I have the batch. Let me see batch step here. I see. I have a filter here. We are applying the 10% discount to prices that are greater than 400. That's what I am doing here. Yeah, otherwise, if the price is less than 400, then it will be as is. So in the examples I included, in this examples, there are no records with price value greater than 400. So yeah, let's just process the whole of it, because the examples we saw were better than this one to understand that the concept. So I will remove this also. Let's make it simpler. This one, yeah, it will just print the summary by itself. Also here I'm printing the payload. So I have the variable before the scope is varus dot var underscore before. The variable from the scope is varus dot var after. This one is not accessible. We said variable created in the scope is not accessible, so this will be null. And the payload is, this payload will be a summary statistics. That is what we should get on the complete stage. So let's insert the diamonds data and see how long it takes. So I'm using batch aggregator, as you can see, and I'm aggregating all of them and inserting all of them. We can experiment first. Let's send 1000 records at a time. Let's make this 1000 and I'll clear the console. I have so in the slides I have this document which is here. You can just create a table. I created diamonds discount table, so that table will have the old price and the discounted price, which is called price underscore new. You just run this like what we have been doing. You just run this and it will create a table for you. So my table is this one. I have already created that table, but there is no data inside it. I just have only the table itself is not there. Okay, yeah, I see only the columns, so I have old price and the new price here. So what we are doing here is, for price values greater than 400, we are applying a discount. So for example, let's say you have a website, you are selling your products, and you have some application that uses the price values. You put them in some database, and at some point in time you want to apply discount to some of your products. And the criteria we are using now is for the diamonds whose price is greater than 400, we are applying 10% discount. And in the batch aggregator, we are inserting 1000 records at a time. So it will send 1000 records at a time. We'll also test with 500 or 100 and streaming and see the time it takes. So here also we can print, let's print the time. Here even we can create a variable. Yeah, the time it takes, we can time it here. The time now is, just use the now function. Oh, now. So it is going to print the time at the end, how long it took. When it prints the summary statistics, it is going to print the time. And I can also create, original, the time before it starts, the time, yeah, let's create even variables. The time before it starts the batch job, let's call it start time. And this will be just now function as expression. And here we'll put start time. And then in here, at the end, let's print, and the time taken is now minus varus dot start time. What error is it giving me? Let me see. Oh yeah. So the time as that time minus varus dot start time. So what we are doing is, it will keep record of the time before it starts the batch job. Then it has the time when it completes the batch job. The difference will be the time taken. That's what we are doing. Okay. Okay, enable this one. Let's put it as okay. What if we put as string? String. This thing you cannot concatenate string and time. So the difference, once it gets the difference, we'll convert it to string. Now it seems it is working. Let's see how long it takes. So I have some data, the diamonds data as a whole data. It is going to, in here, let me add this in the display. Let me add price greater than 400. So discount will be applied for those diamonds with price greater than 400. And this variable, I was creating a variable to understand the scope. We understood it with previous examples. We can remove it. Here we are applying 10% discount. Oh yeah, let me show you the 10% discount. So we are processing one record at a time in the batch step. So since you just have one object, from that object you can create a new object. So as you can see, that object is payload and it has different keys. And from the keys, I am creating a new price here as the price times 0.9, and the previous price, the old price, the price I'm saving it as old price. So we are doing this because we just have one record. Since we are processing one record at a time, it is an object. So that object, you access values from an object using the object name.keys. That's what we are doing. These are the keys, and the object name is payload, and we are creating another object from that. When we have multiple objects, when we pass an array, like when the batch block size is greater than 1, then we have to use map that we are going to see in coming classes. So that's what we are doing, and aggregating 1000 records and inserting to the diamonds discount table. Okay, so now let me go and copy and paste the diamonds data to the working directory or to the input folder. Here I have batch processing input. Let me clear the console first. Clear it. See what updates it gives us. It will give us the summary statistics and how long it took and so on. Okay. Oh, is this running? Okay. And yep, it has started. It has picked it up. It is processing the data. It shows us that it has started the batch job. Default it is 100. By changing this value, gets a corresponding time and record it, and you can plot some kind of, for example, a bar graph, time versus aggregator size versus time taken, and experiment with that. And also the other one we have in the exercise is the aggregator size and batch block size. Yeah, the batch block size is this one. It is 100. Oh, we have the aggregator. I see. Yeah, the 100 by default is batch block size. The aggregator, we specify it here. Can use streaming or put a number we said. So you can experiment with these values, and you can get more insights about how it is working by doing that. I guess it is good if we stop here if you don't have any questions for today.